Okay, now that we have our circuit drawn here, we actually still have a few more steps before we can even export the netlist. So let's actually kind of go back here to our notes and see what we've done so far. So we know this, we know all the parts because I gave you the circuit. I have done this for you. I haven't told you that yet, but I have done that for you for this particular thing already. So we are actually still at this step. Um, we've created the schematic, but we're not done. Our goal is by the end of this video is that we get through to the net list. And then I do think that's where we're going to stop for this week so that we really have time to focus on everything that is required to do the schematic, and that we can have some practice doing the schematic here, because there's actually going to be still quite a bit that we have to do here for this video. All right, so let's get back here. So we've got all the connectors made here. Now, first thing we have to do is we actually have to make sure that all of our parts make sense. And what I mean by that is, let's look at this part for instance. This part here, let's count the number of pins on it. 1, 2, 3, 4, 5, 6, 7. There are 7 pins on this chip, or on this component here. I should say component, because now if I go to my footprint directory and I pull up I opened the wrong file. Yeah, it's going to say, hey, hates me. Double clicked on the wrong file. You can do it. There you go. So if I open this part, we can see though the footprint for this part, the package actually has 8 pins. And then I put a square pad here again to represent where pin 1 is, so that if we were to actually build this circuit, it would be very easy for us to make sure to put the chip in the correct way. Okay, so if there's 8 pins, but then this component only has 7 pins here, we are going to have a problem, because what's going to happen is I'm going to attach a footprint to this symbol. And then the footprint's going to say, okay, I need to match the 7 pins up to the 8 pins. Well, hopefully you see the difficulty there. I'm matching 7 pins up to 8 pins. Well, you might say, well, okay, well, just don't use the 8th pin. But the problem is it's worse than that if you think about it. It doesn't know which 7 of those 8 pins to use. It doesn't know that this is pin 1. Maybe this would be pin 1. So you have to have the pin number be the same for the symbol that's in cadence and the footprint. So our footprint, our package here has 8 pins. So I have to go back here and make sure this has 8 pins. Now, the way we can do this is actually pretty easy. We just right click, well first off, you make sure it's selected. So it's selected by left clicking on it. Then I right click and I go to edit part. And you can see I can actually, and one thing, I mean, we don't really want to do this, but you can actually like slide these pins up and down, if you really want to. So I just put it back there. But if we notice at the top here, there's this place, and all we're going to do is place a pin. And then shape, instead of line, I like to do short, because short is the same as what these other ones. Line is longer. The name, now we want to give it a name of something that's not already being used. V plus is already being used, so we don't want to use that name. And so I'm just going to call this NC for no connection. But if we had multiple pins we had to create, you might want to do like NC1, then NC2, NC3, so on and so on, because all the pins have to have different names. And it's already kind of given us the pin number. It's saying, well, hey, the next pin number that makes sense, because you've already got 7 defined, would be pin 8. You're like, oh yeah, okay. And then you can see I have this little black arrow here, and if I just left click anywhere I want to, it'll put the pin there. And I don't know why, but I like to put the pin here, the 8th pin, when I'm doing this. And you can see now it has no connection here, NC. So then I'm going to close. Now it's going to say here, would you like to update the part instance being currently edited or all part instances in the design? Now, it depends on the situation, on whether you do update current or update all. But in most cases, you would probably do update all, because if you're doing it for one and you have multiple chips of this in your thing, you're going to have to do it for all the others. So even though there's only one here, I'm going to click on the update all. And it says, this will save your entire design, including, do you wish to continue? Yes, I wish to continue. And now we can see there's that pin there. Now, those 3 pins aren't being used, and this OS 1 and 2, there actually are functional pins on the op amp, but we're not using them. So I want to make sure that the software knows that there's no connection going to those pins. I mean, you might say, well, it's obvious because there's no wire. Yeah, but I can make sure that it's obvious here. And what I can do here, well, you can, I think it's under the place. Yeah, no connect. It's also this little red over here, or I know the short key now, which is X. So I'm going to do no connect, and it's this big X, but when you actually left click on it, it just puts a little small x there, small x, and small x. Okay, so that part now is ready. Now there is one other thing that we have to do, and this is a function of the capacitors in the analog library for Cadence, is these electrolytic capacitors are not named well for layout purposes. So I'm going to double click, not double click, I'm going to single click on it and then edit the part. Now it still has 2 pins, and the capacitor we're going to have is 2 pins. I mean, the capacitors have 2 pins, and it has positive and the minus, which is good. But I'm going to select this, and you can do edit properties, or you can just double click it. So I'm going to double click it. And its name is P, which is fine. P. The name is plus, which is fine. But look at the number. The number is P. Well, hopefully we all see what the problem with that number is. And the problem with that number, of course, is that P is not a number. And so we want the positive to be pin 1. And we want the negative here. We have the same thing here, minus sign on the name. The number is N, which is not a number. So I want this to be pin 2. Now, every time you use an electrolytic capacitor for any layouts, you'll have to do this. But remember, if you have polarized components, you really want to make sure to use that so that you make sure you put them in the correct way, because if you put a polarized component in backwards, either the circuit won't work or you could actually blow up the capacitor, which makes a loud, well, it can make a loud noise, and then it kind of stinks then as well. So we want to make sure to do that. And now this is going to show you why updating all. I'm going to hit close again. I'm going to click update all because I don't have just one electrolytic capacitor. I've got 3 of them. So I'm going to do update all. Say yes, I want to do that. But now just to show that we edited this C1, but let's go ahead and look at C2. If I go to edit part and I double click, we can see that's already been renamed to number 1. And if I double click here, we can see that's number 2. So that's the advantage. I haven't done anything, so I'm just discarding it. That's the advantage of doing it with the update all, because in this case, if I'm doing it for this capacitor, I'm going to want to do the same thing for C2 and C3, so why don't just do it for one and then update all of the capacitors? All right, now all of the components are ready to have footprints attached to them. So the way I like to do this is just to either do Control A, which is select all, or drag around everything in the design. And so either way, you want to basically, I like the Control A because then I don't miss anything. But then we have to be careful. You don't want to right click where it's a pointer arrow. You want to right click when you get to a crosshairs. So don't right click with like in here, but it'd be okay to right click here, here, but you want to make sure that you have those kind of crosshairs, or actually maybe cardinal, north, south, east, west kind of thing. And then you're going to go to Edit Properties. Now, there's a lot going on in here, and there's a lot of information. It's easy to get information overwhelmed here. Most of the stuff we can ignore. You can see the names of the nets, which are the wires. You have name 0, we have that input, that output. You might not have this thing. This is because I have schematic nets from going up here, but these are the other names here. And so we don't need to do anything. What we need to do is we have to work with our parts. So we have the parts here. Now there are two views for the parts. I do like this view. However, your view might be this. When you look at this, if you're doing this the same time I'm doing it, you might have it look like this. And you might say, well, this looks actually nicer. And I was like, well, yeah, but the problem is we're going to have to scroll over and find a particular value here. I like it because basically what you have here is the components are listed here, and then all the properties you can change are listed across the top. And it's personal preference. I like it the other way. I like all the properties listed as rows and then the components listed across the top. And there's one very important one here that we're going to need to edit here. And this is the PCB footprint. Now I'll just make it bigger, not for any other reason than just so I can emphasize it easier on the screen. There's no reason to make it bigger like I did here, but it's just so that it's easier for us to work with. Now the other thing I'm going to make bigger is this reference here, part reference, because that will also help us know what footprint to attach to these. Now you'll see some of these names have already been filled in. They never work. I don't know why they're even filled in. The only thing I think is that it's trying to give you something about what are the dimensions that you should be using. But other than that, I have never understood what the purpose of these are. I find it annoying that they're even filled in because it misleads you in thinking like, oh, I don't need to put anything there. Clearly you have to put something where there's a blank, but here we have to put something there as well. Now, I will be uploading these to Blackboard so that you can go along with this, but these are the footprints. Now, for instance, we can see C1, C2, C3, those are my capacitors. Now, using the proper naming convention, this is the footprint for my capacitor. And you can see here again, pin 1 because it's polarized. And for electrolytic capacitors, the longer leg is what would be in the square side. Or there's also a nice little kind of gray, usually, or silver minus sign kind of down one of the sides of the cylinder, and that would be always going in the pin 2. So this is what the footprint looks like, but now I have to type this name in here, and it has to be 100% accurate. Any mistake and it won't work. That does not sound like fun. So let's use some smart thinking here. I'm going to right click on this. I'm going to say rename. I'm not actually renaming it. I'm doing rename because notice how it's now in a blue highlight there. I'm going to do Control C to copy that name. Now I'm actually going to click somewhere else because I don't want to rename it. That's the proper name. But now, if I come here and I hit Control V to paste, and apparently it puts my rows back. Well, so much for having those longer here, but you can see it pastes the whole name in for me. And so then I can just do Control V and Control V for all of them. Wait a minute, it actually did not do what it was supposed to there. On a couple of them, it had the original name in still with it. But you can see I've got it Control V, and you can always check up here at the top. Yep, that's the correct footprint name. So I now need to do that for all of these. Well, the jumper or the header, well, you can kind of guess HDRV 4W6. And the other thing is we have such few parts at this point. If you're not used to the naming conventions, you can kind of just double click them and see what they look like and probably figure it out from there. But if I double click on that one, oh yeah, that's a 4-pin header. You know, okay, so that's good. So I will right click on that, rename, Control C, then go over here, Control V, Control V. Absolutely the way you want to do it. I would not want to try and type these in by hand. I would have all sorts of mistakes. Okay, well now we have R1, 2, 3, and 4, so it's the resistors. Notice how it groups components together. That's actually really nice. So we can just kind of pick one footprint and keep marching through here. Okay, so the resistor, you could probably guess which one it is here. It's RES AD, which is axial diameter. So I'll rename. Actually, let's go ahead and just double click on it so you can see it. So these holes are, of course, where your bead drills would be. This little aqua box here is the actual resistor, and then you would have to bend the leads down. Now I made it so that you'd have to bend the leads down pretty tight against the body, and which is feasible to do. But I could always, if we wanted to, we could have moved these holes out a little bit further. Like I could have put the hole out here, and the hole a little bit further out, but I was just using not necessarily an IPC convention because there's not really a rule for how far away you should go there. A lot of it has to do with how much those arms can bend and where they can bend at, which is honestly more information from manufacturer. So this is such that I know it's feasible to bend them and have them in very nicely on the boards. So I'm going to right click now on that, do a rename, Control C. Let me go back to here. And then I'm going to, see, this is where I made my mistake last time. See how I'm actually in the box now typing letters? I want to hit escape, Control V. And then if I hit enter, you can go back and see there's nothing there. So you have to be careful that you're not actually having, again, I'll show you here, where you have a cursor, because if I do Control V now, I'll just show you. I have AX slash, so that's not the right part name at all, or footprint name. So, and again, I just did it there here. But if you hit delete, I can delete it, or you can just, again, using the arrow keys I'm using to navigate here, and you can just paste over top of it. Now there's only one other component that we have to put a footprint in for, and that is the dip component. And you can probably guess which one it is here. I'll double click on it. Oh, no. Apparently I already have it open somewhere, so let me, yeah. So this is the component. Again, we'd already shown this. It's got that nice little square pin to indicate pin 1. So I'm going to rename, Control C, come here, and you see I got that little thing there, so I'll hit escape, maybe just delete it just to make sure it's blank, and then Control V to paste it in. Now, I'm going to close this, and yours might give you something saying, hey, do you want to save properties or anything like that? I turned that off because I was sick of it screaming at me every single time that I changed a property. But you just say, yes, I want to change the properties. So you would always respond to yes. I'm going to go ahead and save everything. Okay, so now we're actually ready to finally do our netlist. So if we go back to our tasks here, we are now finally done with this schematic, and we're ready to move on to the netlist. Okay, now the netlist won't take us very long to do. It'll be very quick. I'm going to go to this layout here, and under Design Resources, and then there's this DSN. Now you can hit this plus button, and you can see what's here. Like, well, that's page 1, that's the schematic. Design caches, it's basically showing, what are the most recent things that I did, kind of thing. Oh, look, an LM74 resistor, ground, things like that. Don't really care about that. And then outputs, there's no outputs right now. But I'm going to select this DSN and make sure this is highlighted in blue. That's critical. The first thing I'm going to do is go to Tools and Annotate. And we're actually going to just click OK on this. This annotating is basically making sure that we don't have like conflicting part names, like we don't have, 3 resistors all called R1. And I could go through all of this information here, but that's kind of well beyond the scope of this. So whenever you do the annotate, you just do annotate and you just click OK. Now it's going to say this will annotate and then save your design. Do you wish to continue? Okay. So it annotated, and it said, okay, done updating part references, and it says last used references, goes through there as before, so it updated the parts references for us. Now, I still want to have this DSN file selected, and then I'm going to do Tools, and I'm going to do Create Netlist. Now, by default, it says that it's going to store its files in a netlist directory. So what does that mean by that? Well, for instance, if I go to, no, that's not where it's going to be. I don't remember if I'm saving this here or not. Yeah, layout 1. Okay. So we have this layout 10/8/2021. So first off, if I go in this layout 1, oh, apparently it's directory. It's empty. That's good. If I go in here, it's empty as well. But it's basically going to create a directory called Allegro inside here to store the netlist files. Now, you don't have to put them in there. However, it's recommended that you do. So, but again, depending on what your company would have you do, there might be a different directory that they save all of their netlist files in. So I'm going to click OK. Now you could check this box to view the output, but I'm going to show you another way to view the output. And then hopefully it doesn't go by too quickly on my computer. If it does, I'll show it to you again. It's going to say, first off, hey, there's no directory. Do you want me to create it? And then you say yes. And then right here, it went away really quickly there. And my computer's fast enough that unfortunately you can't see what happens there. But normally, if you have a longer design or a bigger design, or if you're using one of the school computers, you might see a little couple green check marks. And so let me try and do that again here. Create Netlist. And you can see, and then you could just see there. Um, you might have to go back and do like slow motion of the video, and maybe you won't see it because of the way YouTube compresses the videos. But there was just the fraction where you can see one of the green check marks showing, but mine goes so fast. So um, if there's an error, we'll know that there's an error because it would give us something down here. Now that doesn't mean everything worked properly, but there was no error, at least on this side of things. So let's look here, the outputs. We now have 3 outputs. These are the netlist files. The good news is you don't really need to be able to read these, but I will go ahead and show you a little bit here. So if we look at this PST and then, okay, PST part, for instance, what do we have here? It's got information about the parts as far as the footprints and everything else like that. And yeah, so what is, you see part name C1, and then it's got the footprint here. And then it's got a bunch of other stuff here. C2, footprint, bunch of other stuff. And then right here, it's got different nodes that it's naming. So a node that it's naming, like it's got node C2, node 1, J1, node 2. And you might say, well, how, like, for instance, C2 node 1 and C2 node 2. Well, you can kind of think of it as, well, it's got, you know, different pins. Like if you go and scroll down here, you're going to see all the U's having, you know, U1 here, U5, U8. I mean, they're not in order. I don't know why it doesn't go that way. But then you even see net names here as well, NC and things of that nature. And then it's also, this one's got the chip data as far as it's got information about the parts here. So this is again the footprint, pin number 1, it doesn't have the pin used, we didn't specify, that's fine. Pin 2, but then it has here value 4.7 microfarad, you know, so on and so on. So it's got all of the information about all the different parts. And so this information, this actually contains, all of these 3 files contain all of the information that the next program needs in order to establish all of these different components, put them with the correct footprints so that we can actually put them on a board, lay them out, and then route them together. But I definitely am going to do this next week. If we're looking at the time here, some of you might wonder why I don't make these super long sometimes. Like you might say, it's like, well, he doesn't seem like he has a lot of videos. Well, this is an online course, so instead of trying to, you know, and I know some of you might feel like that still is a lot of material I cover, but if it was during the week, you know, this would be like 1 class period's worth of lecture, and we're ending at 30 minutes, but there's no interaction with you guys. And so, and I understand that, you know, it would be nice to have that interaction. So I don't go the entire time because I'm assuming that, you know, well, we'd have, you know, answer questions at the beginning of class, you know, doing things, you know, you might have a question as I'm going through things. Speaking of which, again, if you have questions, I've sent this out sometimes, feel free to email me. You can set up an appointment. I know my schedule is busy, but you can always set up an appointment to meet with me, or we have a lab TA that you can use as far as getting in contact, and I sent you guys some information if you need some assistance on some things. And actually, I believe there's even a schedule for the lab now posted outside 211. All right, so we'll end here, and hopefully you guys are going to continue to do well in this course. And the next week we'll finally get into doing our board layout. We'll also be starting soldering soon. Basically, as soon as my lab tech can get all the boards etched, we'll be soldering. So.